We're going to look at the elimination method for systems of equations, and we're going to start with an example like this, but we're going to see several others as well, including one with fractions. Now, when we're solving a system, our goal is to find the XY pair that together make both of the equations true. With elimination, our strategy is to get rid of one of the variables and then solve for the other. Let's go ahead and dive in with this first one, and I want to go over our first few steps. We want to start by picking a variable to eliminate, to get rid of. And I really want one where the coefficients are opposites. And in this case, the y's are the perfect match because I've got a -1 as a coefficient of one of them and a +1 as a coefficient of the other. So I'm going to take my two equations and I'm going to add them together. And as I'm doing that, those y's are going to eliminate. So just working my way down as I'm adding these two equations together, I've got 2x plus 1 more x. That's going to be 3x's. And then -y plus y, those go away and I get 0. And then on the other side of my equals, 1 plus 2 is equal to 3. See that I've got this really nice equation to solve now for the x. So as I'm solving, I want to divide both sides by 3, and I get x is equal to 1. But remember that we're solving for a pair. We're really looking for an x and a y. So far we know that x is equal to 1. So this is where our next step comes in, and that is to substitute to find the other variable. Now you can substitute into either of these equations. It really doesn't matter which one you pick. I'm going to go ahead and pick that second one because it just seems a little bit easier. So I'm going to take that x plus y is equal to 2, and I'm going to take my x equals 1, and let's go ahead and plug it in there. So I end up with 1 plus y is equal to 2, and I'm easily able to solve for y. Subtract the 1, and y is equal to 1. So the 1 and the 1 together, the x and the y together, give me my solution of 1, 1, or you could write these out as their values. X is equal to 1, y is equal to 1. Now in this example, we came up with a single solution, which means that of the 3 different possible cases we could have got for our solutions, we are getting this first one. My two lines cross at a single point, and that point is our solution. Now we're also going to see an example of one of these other two. These are our special cases where they're either parallel or the same line. In our next one, I again want to pick a variable to eliminate, but it's not quite as obvious as I'm looking for those opposite coefficients, so they'll just go away. So on the x's, I've got a 1 and a 3, and on the y's, I have a -3 and a 5. Well, it turns out that the x's are going to be what we want to choose because the only one I need to change is that first x. I want to make its coefficient a -3. We're going to do this by multiplying. So let's go ahead and take our equations, and I'm going to multiply that first equation by a -3. Every single thing in this first equation is going to get multiplied by a -3. So as I distribute that, I end up with, let me get it back to black, -3 times the x is -3x, which is exactly what I wanted. And then -3 times the -3y, that's going to be plus 9y. Don't forget about the other side. -3 times -5 is equal to 15. Now I don't need to make any changes to my other equation, so I'm just going to go ahead and bring that one over. 3x plus 5y is equal to 13. Now you can see that I've got those opposite coefficients on the x's, and I'm ready to add these two together. So as I'm adding these together, my x's are going to cancel, -3 and 3. 9 plus 5, that's going to give me 14y. And on the other side, 15 plus 13 is equal to 28. I just need to divide both sides by that 14, divide by 14, and we have that y is equal to 2. But remember, we were looking for a point. All we've got so far is that 2, so I'm ready for that last step. That last step is to substitute to find the other variable. So I want to go back to those original equations and let's go ahead and plug y in. Doesn't matter which one you pick, but I like to pick the easiest one. So I'm going to choose that first equation. Let's move this up. I'm going to choose that first equation. X minus 3y is equal to -5. I'm going to take that y equals 2 and I'm going to plug it in right here. So I get x minus 3 times 2 is equal to -5. X minus 6 is equal to -5. Move this up a little bit. I'm going to go ahead and add that 6 to both sides, plus 6, and we get x is equal to 1. So putting our two values together, I've got 1, 2 as our solution, and I know that this is another case where my two lines cross at a single point. In this next example, we are going to look at one of our special cases. So you know that those two special cases is one that's parallel with no solution, or one where the two lines happen to be exactly the same thing, and that's where we've got infinitely many solutions. So let's see what case this one is. Now we want to start by picking a variable to eliminate, but I noticed that my variables are not in order. I want to get both of these into general form. Variables on one side, numbers on the other. The first equation is exactly how I want it. So I'm going to go ahead and keep that x minus 2y is equal to -5. But for the second equation, 6y equals 15 plus 3x, I really need that 3x to be on the other side. So I'm going to subtract my 3x, and let's go ahead and line everybody up. So I've got the x's first, and then the y's, and then the number on the other side. So that's going to give me -3x plus 6y is equal to 15. Let's go ahead and bring the other equation down, which was x minus 2y is equal to -5. Now that I've got my two equations, let me put a box around those. So now I've got my two equations here. I just want to decide which one I want to eliminate. What variable, the x or the y, would you choose to eliminate? Well, it turns out it really doesn't matter. We're going to end up doing the very same thing, whichever one we choose. The one that jumped out at me were the x's, but you could also choose to eliminate your y values. So I am going to go ahead and multiply that second equation. Let me get rid of that guy. I'm going to multiply that second equation by a 3. But I'm going to bring that first equation over. So I get -3x plus 6y, no changes here, is equal to 15. And to match those opposite coefficients onto my x's, I need a +3 on the second x. Okay, so let's go ahead and multiply to get there. I end up with then that +3x. I'm just bringing that 3 on. 3 times -2y gives me a -6y. Notice what's going to happen here. And then 3 times -y is a -15. Now I know that I want to add these together next. So as I add these together, I end up with not a lot. My x's cancel, my y's cancel, and I get 0 on the left, and I get 0 on the right. So I get 0 equals 0. My variables go away. So this tells me that this is a true equation. No matter what x and y are, this is a true equation. So I know that this is going to end up to be the case where these are the same exact line, same line. So to express our answer, I want to go ahead and express this as all of the points on the line. So as I move this up, I'm going to go ahead and put this into set builder notation. Now this is not every point. This is not all real numbers, but it's all the xy pairs on that line. So it's going to be the set of all the points. So x comma y just represents any point, My condition comes on the other side. This little bar means such that, and I can put in either equation. Of those two equations, I'm just going to grab the first original equation, x minus 2y is equal to -5. You could choose any of them. Again, this means all the points that are on this line, but we do have infinitely many solutions. Here's our next one. The first equation looks good. I've got my x's and y's lined up, but in my second equation, not only do I not have the x and y's on one side, I also have some fractions. But the really nice thing about equations is that you can clear those fractions. So I'm going to go ahead and start by multiplying that second equation, both sides, by a 4. So I've got a much better looking equation. So I'm going to do that. So 4 times this side and then 4 times everything on the other side. So that is going to give us 4y is equal to 4 times 1/4 x. 4 times 1/4 is 1, so I just get an x. And then 4 times 3/4. My 4's are going to cancel, and I get -3. I'm almost to where I want to be. I just want my x over there on the other side with that y. So let's subtract the x from both sides. I get -x plus 4y is equal to -3. Now that I've got it in this form, no fractions, and I've got variables on one side and my numbers on the other, I can bring down that other equation. -5x minus 2y is equal to -15. Now I know that I need to choose either the x's or the y's to eliminate. Which one would you eliminate? You really could choose either one here. If you chose to eliminate your x's, you would multiply this first equation by a 5. If instead, and this is what I'm going to do, if instead, like me, you chose to eliminate those y's, you want to multiply the second equation by a 2 to get those opposite 4's as your coefficients. So I'm going to go ahead and multiply the second equation by a 2. Let me make a little more room here. And here we go. So I'm going to multiply the second equation times 2, multiplying everything by that 2. I end up with -5 times 2. That's going to be -10x. -2 times 2, there's my -4 coefficient that I was looking for. And then on the other side, 2 times -15 is going to be a -30. Now, nothing to change with that first equation, so I'm just going to bring that guy over. -x plus 4y is equal to -3. Now I'm ready to eliminate those y's by adding my equations together. So I end up with negative, I'm going to think of that as -1x minus 10x, that's -11x. And then my y's, 4 minus 4 is equal to 0. On the other side, I get -3 minus 30, it's going to be a -33. We're almost there to our x value. Divide both sides by -11. And x is equal to -33 divided by -11, which is equal to 3. Now remember, this is part of our solution. I've got the 3, but I still need to find my value for y. I want you to pause the video, go back and find y, start it up again, and see how you did. Now you can choose either of the original equations, but I definitely want to choose the one without a fraction in it. So I'm going to choose -5x minus 2y is equal to -15. You could, though, even choose the one where we cleared those denominators. Any of these equations will work. But I'm going to plug in my value for x, which is 3, right into x right here. So that is going to give me -5 times 3 minus 2y is equal to -15. So I get -15 minus 2y is equal to -15. I'm going to add 15 to both sides. You see what we're going to end up with here, plus 15. I get negative 2y is equal to 0. Divide both sides by negative 2, and y is equal to 0. Now we had 3 for x, so that gives me a single solution, and that solution is 3, 0. You are doing great. In my next video, we're going to look at another method for solving systems, and that one's by substitution. Thanks so much for watching.